Guys, welcome back, and today we are going to be reviewing what we learned from 2.1 to 2.3. We took a little detour because I thought we needed that break to make sure that we were up to up to par on where we should have been. So this is just going to be a review, so I'm going to go pretty fast through it because we should have all seen this before. But for think/warmpy, what was our zero product property, and our zero product property really just said that anything times 0 is going to be 0, so that if you have something times something else, one of them or both of them have to be 0 for this to be true, and we'll work with that with some of our review problems. And to get our minds back into the right place, remember when we started multiplying these two binomials? So if we had multiplication here, we did x times x first, which was x squared, and then we did x times minus 6, which would be minus 6x. And then we did minus 5 times x, which is minus 5x. And then we would do minus 5 times negative 6, which is positive 30. And then this is why I did that review, right? Because we need to know that x times x is x squared. We need to know that negative 5 times x is negative 5x. And then we also did that review because we need to know that x squared minus 6x minus 5x, that's combining like terms. That's another reason I did the review. It's going to be minus 11x plus 30. And, we just kind of need to remember that this thing here is the same thing as these two binomials, right? They're just expressed differently. So when we multiplied them, we got this little trinomial, right? Tri, because there's 3. And factoring is when we went backwards, right? Factoring is when we went backwards to here. So I say, remember, factoring was going the other way. So if I told you to factor x squared minus 11x plus 30, we would do that thing where we make our x and we say we need to multiply to that last number 30 and add to the middle number negative 11, because that's what happened when we multiplied these out, right? We got this plus 30 from multiplying these last two numbers, and then we got this negative 11x from adding negative 5 and negative 6. So that's why we're following that pattern in order to go backwards. And you would say the two numbers that do this are negative 6 and negative 5, because added together they're negative 11, multiplied together they're positive 30. So once you find those for these, all you do is x minus 6 and x minus 5. And then just as a refresher, if we were to factor something like this where we have a 6 in the front, remember we would do 6 times negative 10, which is negative 60. We would just multiply the first and last, and then we do all the same steps. We do multiply to negative 60, and we need to add to negative 11. Now, what two numbers do that? Sometimes I find just listing the multiples helpful. So if I do 1 and 60, that's not going to get us there. 2 and 30, 3 and 20, 4 and 4 and 15. 4 and 15 looks like it does it for us, right? If we do a negative 15 and a positive 4, right? So what we do with that now is we're going to make this box do my best, and we essentially are going to rewrite this. So this 6x squared is going to go on the top, this minus 10 is going to go here, and this negative 11x is going to go here, but in the form of these two numbers. So I'm going to put 4x there and negative 15x there. And again, that's where this 4 and negative 15 are coming from. I just slapped an x on them because I'm kind of making together these are negative 11x, right? Negative 15x plus 4x is negative 11x. So that's why I put those x's on there. And then I'm looking, what can I factor out of the top two? I see that I could take out a 2 and an x from both. Then I'm asking, what multiplies here? 2x times a what gives me 6x squared? Well, 2 times 3 gives me 6, and then x times x gets me x squared. And then the rest, I keep doing the same thing. 3x times negative 5 is going to get me negative 15x, and then negative 5 times positive 2 is going to get me negative 10. And so then that's how I factor those things, right? The 2x minus 5 is up there, and the 3x plus 2 is there. And that's just a reminder how to factor. So for solving quadratic equations, this is where we use our zero product property. If two things multiplied together are 0, then one has to be 0. And so the keynote for these was, remember that we need 0 on one side. So in order to do that, I'm going to subtract 5x and subtract this 5 over. Subtract 5x, subtract the 5, right? Because then those will cancel and I'll get 0 on that side. So really what I'll be left with is x squared. Negative 11x minus 5x is going to be minus 16x. And then 68 minus 5 is going to be plus 63. Then we're going to have 0, which is what we wanted. And now we wanted to factor again, which is why I did that super quick review. We want something that multiplies to 63 and adds to negative 16, right? And again, you could start listing these, right? We have 1 and 63. That's obviously not it. We have 3 and 21. Well, that's kind of close, but not really there, right? So what else do we have? 4 is not going to go into there. 5 is not going to go into there. 6 is not going to go into there. 7, right? 7 and 9 are going to go in there. So I need to pick up my pen. 7 and 9 are other ones. Oh, and I think together those make negative 16. So if I have negative 7 and negative 9, that'll add to negative 16, multiply to positive 63. And so I know that this can be factored into x minus 7 and x minus 9. All right. And these two are the same things, right? I just messed them up, or I just changed how it looks. So now, if we remember, I'm going to set this side, now that we have it equal to 0 and we're actually solving, I'm going to set both sides equal to 0. And I'm just going to add the 7 over. And add the 9 over to solve for x. And those are my two answers, right? And that makes sense because when x is 7, 7 minus 7 is 0 times, it doesn't even matter what that thing is going to be 0. Same thing when x is 9, 9 minus 9 is 0, times whatever this is going to be, doesn't even matter, is 0, so it's going to be true. So that's how we solve for x there. And if you were to plug 7 into this equation and work this out, you would get 0, right? That's the whole point, is this and this are the same thing. So for the graph, we have, I just want to point out some important features. That is called the vertex. That's called the vertex. We have 2 points here and here that are called the x-intercepts, or the roots, right? Just another word. And then here we have the y-intercept, right? And it's x-intercept because that's where it crosses the x-axis, and then that's y-intercept because it's where it crosses the y-axis. And you just need to get comfortable with the word roots as well. And then keep in mind, we also had this, we had a axis of symmetry, right? So like right about, if I can get it here, we had what we called the axis of symmetry. Because that's where you can fold the parabola on itself. That's where it's symmetrical. And take note that that is on the vertex. So these are just things that you have to write down. I'm not going to spend a whole lot of time on it because this is just what things are. Axis of symmetry is x equals negative b over 2a. You can pause this video and write all of this down if you need to. For the x-intercepts and the roots, you set y equal to 0, solve for x, because when you are at an x-intercept, you haven't gone up or down any, right? These are the x-intercepts and the roots, so we haven't gone up and down any in the y direction, so the y value is 0, which is why we plug that in. And then for most of these guys, keep in mind that we are expressing these as points. The y-intercept similarly set x equal to 0, solve for y. And it's because when you are at the y-intercept, we haven't gone left or right any, so the x value is 0. So find the equation of the axis of symmetry, the vertex, the roots, and the y-intercept of this equation. Y equals x squared minus 2x minus 15. So let's do the axis of symmetry first. And that was just the equation x equals negative b all over 2a. And here we have a equals, we have an invisible 1. B equals negative 2, and C equals negative 15. So x equals negative, B is negative 2, all over 2 times A. A is just 1. Negative and a negative is going to be a positive. 2 divided by 2 is just 1. So that's our axis of symmetry. Let's do our vertex now. Maybe I'll do it in a different color. Now our vertex, we're going to plug in x equals 1. So we have y equals, wherever I see an x, I'm putting a 1 in parentheses because I'm plugging in 1 to the equation. So we have y equals 1 squared is 1, 2 times 1 is just 2, and then minus 15. So really what we have is y equals 1 minus 2 is negative 1, minus 15 is negative 16. Now the vertex is a point where we have an x and y value. We set our x value as 1, and our y value is negative 16, right? Accidentally hit a button. So there we go. Now it wants the roots and the y-intercept, so maybe let's switch the color again. I'll rewrite the equation. Let's rewrite the equation in black. We had y, or maybe I can just, I'll move it. So y equals x squared minus 2x minus 15. And now let's do the roots. So the roots was the same thing as the x-intercepts, and to find those, we were just going to set y equal to 0. So when we do that, we get 0 equals x squared minus 2x minus 15. Now we're going to use our zero product property. This is why it all ties together. And to do that, we want to factor two things that multiply to negative 15 and add to negative 2 is going to be negative 5 and positive 3. And then once I split this up, then I'm going to get x equals, I'm going to add that 5 over, and then here I'm going to subtract that 3 over. But now we're talking roots. We're talking points on a graph, right? Because remember, when we back here, the roots are points on a graph. So we need to express this as points. And so to do that, we need to actually write some points. And we found two x values. We have an x value of 5 and another one of negative 3. And then we said up here that the y value is 0. So 0. And those would be the 2 points on the graph. Now let's do the last thing it wanted. It wanted the y-intercept. So let's do the y-intercept. And that was when x was equal to 0. If we have x equal to 0, then we have y equals 0 squared minus 2 times 0 minus 15. So really, those go away and we just have y equals negative 15. So x was 0, y is negative 15. That one was not too bad. So now, for graphing these things, we're going to do everything we've just done, except now we're just going to plot those points. So let's plot 5 points, including the roots and vertex. So let's do the roots first. Roots, again, is when y is equal to 0. So we're going to have 0 equals negative x squared plus 2x plus 3. And we want to factor this, but we usually don't have a negative here, so let's just divide everything by negative 1. 0 divided by negative 1 is still just going to be 0. This is just going to switch all the signs. So we're going to have x squared minus 2x minus 3. And now we would factor that. If you have to make the x off to the side, go ahead and do that. But as I said, I'm going to kind of go through this one kind of fast because it is just review. Two things that multiplied to negative 3 that add to negative 2 is going to be minus 3 and positive 1. Then we have x minus 3 equals 0, x plus 1 equals 0. So x, add that 3 over x is going to equal 3. Subtract that 1 over x is going to be negative 1. But these are really points, 3, 0, and negative 1, 0. Now it wants the vertex, right? So let's do the vertex over here. To find the x value of the vertex, we're going to do x equals negative b over 2a. I'll write it out, negative b over 2a here. So negative b is positive 2, all over 2 times a is negative 1. Negative and a negative is going to cancel, and we're going to be left with 2 divided by 2, which is going to be a positive 1. Now that we have that, we can plug that in to find our y value. So then we have y equals negative, wherever I see x, I'm going to put a 1 in parentheses, because that's what I got for my x value. 2 times 1, right? I'm looking at this equation up here. I'm rewriting that, except replacing x with 1 plus 3. So I get y equals 1 squared is just 1, that negative's on the outside, plus 2 plus 3. So really, we have y equals positive 4. And again, that is a point, 1, 4. So, let me rewrite that. 1, 4, right? Because we said x is 1, y is 4. Now let's go plot these. We have 3, 0, negative 1, 0. So we have, let me get a little closer than that. So we had 3, 0, and we had negative 1, 0, and we said, what was our vertex? Our vertex was 1, 4. So 1, and then 1, 2, 3, 4. And then it said we needed 5 points. So let's find one more and then use our symmetry for the other. So it said we needed 5 points. Let's just pick something super nice to plug in. We could plug in 0 for x because we have nothing there. So let's plug in x equals 0. When x equals 0, right, if x is 0, we're going to have y equals negative 0 squared plus 2 times 0 plus 3. So those two things aren't even going to matter. We're going to have y equals 3. So really we have the point 0, 3. And so if I go over here to plot this, we're at 0 and then 1, 2, 3. And then symmetrical across from what would be the axis of symmetry at this vertex would just be over here on the other side. And then Delta Math would nicely sketch that for you, and I'll do my best with the tablet. That's actually not horrible, but Delta Math would sketch that really nicely for you. But that should quickly wrap up the review for 2.1 and 2.3, and hopefully that wraps together all the ideas that we have been talking about.